Welcome back. In this lesson, we're going to look at seawater. We're going to look at the components of seawater, what's involved in making seawater, what would the recipe for seawater be. We're going to look at the salt in that seawater, where the salt comes from, and the cycles that the ocean employs to maintain salt water. Of course, there's water in it, but there's a lot of stuff dissolved in it also. So there's solids dissolved in it, specifically minerals like salts. And not just table salt, which there's lots of table salt, but there's various salts dissolved in water. There's also gases dissolved in water. Fish breathe oxygen the same as you do. So the oxygen that's dissolved in the water will determine whether you have a place that's healthy enough for fish to grow. If you had no oxygen in the water, the fish would die. In fact, you can have whole fish kills if something steals the oxygen out of the water. So there's numerous gases dissolved in the water. Anything, say an underwater volcano, those gases, much of that is dissolved in the water. And salts and minerals that are dissolved from mountains. So you have weathering that occurs on a mountain, it goes down a river, gets into the water, and then is dissolved. Often this is dissolved into the water. Now the main material that we know ocean water is for its salt, and salt is saline. So a saline solution is a salt solution, so salt water. And the salinity is based on a concentration. And in ocean water, it's normally measured in parts per thousand, ppt. So a part per thousand means 1 part in every 1,000, or 2 parts in every 1,000. Ocean water is usually about 35 parts per 1,000. So it's out of every 1,000 grams of seawater, how many grams of salt would you find if you boiled that seawater off? That's how you would find it. Now, in various places, you're going to have different amounts of salt water. Some are going to be very salty, others are going to be less salty. It does depend upon the temperature of the water and pretty much where that water happens to be. So one ocean to another ocean can have different amounts of salt, depending upon what's causing the salt to be in the ocean to start with. And we'll see that pretty much the salt is constant. There's a constant salinity rate in the ocean. The oceans don't gain more salt and lose more salt, but they pretty stay regular. Now, whenever you have a huge river that's dumping into an ocean, that water from the river is going to be fresh water. So fresh water mixed with the salt water means that the salinity in that region is going to be lower because it's being diluted by the river water. That's called an estuary. So an estuary is it's called brackish water. It's half salt water, half fresh water, or partially salted water. And then you're going to see that whatever this would happen, that particular water usually is going to be flowing around the entire ocean system, and so you're going to get a mixture of that salt water. Now, you can get salt from volcanoes because there is chlorine that's coming out of volcanoes. You can get salt from rocks that are breaking down. So rocks that have been weathered, say at a face of a mountain, and then comes down a river, and eventually that dissolved material gets dumped into a bay that is then connected to an ocean. So there is new salt coming into an ocean, but there's also salt being lost. So you can have right at the coast, you could have water that would, say, slosh up on the land, and then that water would dry off and the salt would stay there. Those are called salt flats. And you'll have that's a lot of times where people will mine salt at a salt flat. You can also have salt that then blows on to land and then doesn't return to the ocean. So you do have ways of losing salt and gaining salt, and pretty much it stays the same. Another big drain for salt is critters that are making shells, because the same stuff that is in the salt is the same stuff that is being put into the shell. So calcium carbonates, calcium sulfates, these are being absorbed by these marine organisms and put into shells. Now, when that marine organism dies and the shell eventually dissolves, then that is returned to the water. So there is a cycle as we're talking about this. Now, another thing to remember is that the saltier the water is, the more that something is going to float. So salt water is very dense and it sinks. So if you were to have, for instance, a pond near a salt mine, you can float in that water and not actually go underwater. I've swum in a pond that was a salt water pond, and there was so much salt in this water that even if you tried, you couldn't go underwater. It was the weirdest thing, because it was almost like you were sitting on top of the water. You were kind of in it and kind of on it, because the salt water is more dense than you are, and you float like a cork on top of the water rather than being in the water, like if you're swimming in a lake, which is pretty cool. Also, the temperature of the water will determine whether it's dense or not. So cold water is more dense, warm water is usually less dense. Now that is interesting, because if you have warm water, it normally sits towards the surface, and the colder water will sit towards the bottom. So you have layers inside the water of different densities. The denser sinks to the bottom, the less dense sits to the top. Okay, so you're going to see that it absorbs heat and it absorbs light. Now, water doesn't let light shine all the way to the bottom, so there is a light region of the ocean, and then there's a dark region of the ocean. And so whatever you would imagine that needs light, those are only going to live on the surface of the ocean. They're never going to live deep. Animals that live deep many times won't even have eyes because they don't need them. Or they'll glow in the dark, which is pretty cool, which you would look at in biology. This is what I was talking about a moment ago with the thermocline. If you have hot water on the top, cold water will sink to the bottom, and so you're going to have these definite layers of hot and cold. I don't know if you've ever jumped into the lake. If you're swimming in the lake, you can actually feel where that line is, that there's hot water above a certain line and cold water below a certain line, and that's called the thermocline. Thermo meaning heat. Okay, so you can have these transitional. Now, so I need to help you to think. You can have denser water because it's cold, less dense because it's warm, so that will form layers. And you can have denser water because it's salty and less dense water because it's less salty. That means that in the real world, you are going to have layers of water. You're going to have very cold water from the Arctic or Antarctic that dumps to the bottom of the sea. Then you're going to have very, very salty, cold water from the North Atlantic there, and then intermediate. Then you can have layers of warm and a cooler water on the surface. That would be even warm water that's going in currents, say like the Gulf Stream. Very, very salty, but very, very hot, so it'll float on the top. So you can have these striations or layers inside the ocean water. And then these intermediate is going to be the cold goes to the lower and the warmer towards the top, based on different kinds of salt and based upon different kinds of temperature. So there's the very beginning lesson of how salt water works, and we'll see how that salt water affects other things.